In this tutorial, we are going to solve this question, August 2024, Teveta exams, question 4. The question goes by, given that the maximum moment induced in the beam is 4 kilonewton meter, determine the following. Number 1, the position of the neutral axis. Number 2, the moment of inertia about the neutral axis. Number 3, the maximum bending stress. So that is the diagram over there. Let's take a look at it. So the first thing, as we said, is to divide this beam into parts. So I'll say this is part A, and the middle part is my part 2, and the bottom one is part 3. So I'm counting from 1 to 3. Okay. So remember, they have asked us questions. Number 1, need to find the neutral axis, which sometimes will go like that. That is number 1. Then in number 2, they have asked us to find the moment of inertia, or the second moment of area. And in number 3, they have asked us to find the maximum bending stress. So the first thing that we do is to find the neutral axis. Now remember what we said. We use the table to find the neutral axis. So I'm going to do a table here. Okay, I'm going to write a table. So that should indicate the part number for me. Then I'll say, because there are 3 parts here, I'm going to say part number 1, part number 2, and part number 3. Okay, so I'm going to further divide it in 2 rows. Okay, so in this one, we are going to find the area, which should be obviously in square millimeters. Here we are going to find the center of gravity for each of these parts. And in the third column, we are going to multiply area and the center of gravity. So area multiplied by center of gravity. So this should give us the correct figures. Okay. Now, first of all, we need to find the area for this one. Okay, area. So area for one is here. So it's 100 by 40 or 40 by 100, whichever you take, its area. So I'm going to say 100 by 40. Now I'm not really going to write this because of space, so just follow closely. 40 by 100 or 100 by 40. So 100 by 40, get your calculator. That should give you 4,000. So that should give you 4,000. I like putting commas because it helped me to check if I've written my my figures correctly. Then I go for area for 2. Area for 2 is as well 40 by 100. So this thickness is 40, then the height is 100. So it's also going to give me 4,000. Then when I come to the third one, I'm going to multiply 120 millimeter by 50 millimeter, which on my calculator should give me 60,000. So I have solved the first part, and I can sum these up. You see, so I have further, let me say, the summation. Okay, so this is very easy to sum. This is 10,000 plus 4,000. That should give you 14,000. Okay, now let's talk about the y for 1. So remember, in the previous lesson, we said it is from the bottom up to the middle of that. So the middle of this is here. The middle of 40, it's 20. So we have got 20 down here, 20. So I have 50 plus 100 plus 20. So it is moving from the bottom here up to the middle point here. That is y1. Okay. from the bottom to the middle point. So it is 50 plus 100 plus half of 40, which is 170. So this is going to give me 170. Remember the units again, this is millimeter. Okay. Right. Then we are going to go to number 2 from here. So number 2 is going to move from right here where we are moving up to the middle point there. Up to the middle point, that should give me number 2. So it is 50 plus half of 100, which is 50 plus 50. That should give me 100. That should give me 100. The third one, I'm just moving from here up to the middle point of this. I hope you people are able to follow properly. So that should give me just 25. Okay, so here I have got no need of summing this because I'm not going to use it. So I don't want to waste my time. Right. Then the last one, remember, we have to do the multiplication and the units. Millimeter to the power 3. Why are they millimeter to the power 3? This is a single millimeter, this is a square. So once we do that, we sum the powers. So get your calculator and multiply this and that, multiply this and that, multiply this and that, and put them there. Okay, so that should give you 4,000 times 170 should give you 680,000. Then 4,000 times 100, this is from even the head you can multiply. This should give you 400,000. Then 6,000 by 25, that should give you 150,000. Okay, that's if you do your computations very well. Then we sum this as well because we need that. So when we do 680,000 plus 400, that should be 1,080,000. Then plus 150, that should give you 1,230,000. So 1,230,000. So this is how we do our table. That's how we fill in the table. Right? That's part 1 of the question. I would want to make an emphasis of finding this. This is where the big issue is on the table. See how I've done from the bottom to the middle of the first one, from the bottom to the middle of the second one, from the bottom to the middle of the first one. That's how you get these tables. So if you are finding 1, it's from the bottom to the middle of 1. When you are finding for 2, it's from the bottom to the middle of 2. When you are finding 3, it's from the bottom to the middle of 3. That's how these figures come out. So for this one, it is 50 plus 100 plus half of 40, which is 20. Then this is from here to there, which is 50 plus half of 100, so it gives us 100. And that one is 25. Okay. So now, remember that we are interested in question 1 to find the neutral axis, because that's what we have been asked to. So the neutral axis is always the summation of the area by that over the summation of area. Though it doesn't matter whether you write this one or not, because we have already figured it out in the table. So get this one on top and this one on the bottom. In short, you divide this one into that one. So that should give you 1, 2, 30, 0, 0 divided by the 3 zeros here, 14,000. Okay, the answer here, put that in the calculator. It should give you 87.86 millimeters. So that is our neutral axis. So you can tell that if this is 50 and then this is 50, so the neutral axis should be somewhere there. That's where the neutral axis is. So from the bottom to the neutral axis is equal to 87.86. Okay, very important. So we are going to remove this because we have found the first answer. That's what we needed. So we are going to remove that one so that we can now go to number 2. So the neutral axis is 87.68. That's how we find that one. So copy this down in your book, because we are going to still refer to the area. We are going to still to refer to this as we go into part 2. All right. So part 2 is asking us to find the moment of inertia. Now, remember that the formula for moment of inertia is BD to the power 3 over 12 plus AH squared. Okay. Now, remember, we said H is simply the distance from the neutral axis to the center of gravity of the individual part. You can refer that to the area tutorial, to the area lesson that we had. H is a distance from the neutral axis to the center of that to the center of the given part. So what we are trying to say, just for the sake of revision, if I have to find the H for this one, I have to move from the neutral axis to that. Okay, if I have to find the H for part 2, I have to move from the neutral axis to the middle of that, just like that. Okay, so we're going to begin by finding the moment of inertia for 1, then we find the moment of inertia for 2, we find the moment of inertia for 3. Once we sum these, then we get the total moment of inertia, and that will be our final answer. Right, so very, very important, and I have to emphasize that, remember that B is always like that. From the subject perspective, remember we said B is always that, D is always that, because our neutral axis is in the XX. Okay, that should be very important to remember always. Don't mix up the stuff. Okay, so let's begin by finding the moment of inertia for 1. So we are going to have BD1 to the power 3 over 12 plus A1 H1 squared. Now, remember that A1 you already have from the table. So the table that we did at first, the first column had the area. So there is no need for you to calculate this. All you have to calculate is H1. Now, I like always calculating these things in advance. So I would go, first of all, calculate H1, calculate H2, calculate H3, so that I can have these figures, so that once I begin solving, I just go straight forward. Okay. So now, this is very simple for now to calculate. We are not going to use the method that we used in the first lesson, but it's true the same, but I just want to show you perhaps the easiest way to find it. Remember, you guys, your table looked like this. Okay, your table looked like this, where you had the part number here, you had your area there, then you had your Y there, and then you had your multiplication of that. Here, I think we had the 4,000. We had 4,000, we had another 4,000 here, then we had the 6,000. Check your box. Then here we had 175, here we had 100, and here we had the 25. Okay, then the numbers, these big numbers, continued here. They are not of necessary for now. Now, this was part 1, part 2, and part 3. For you to find the H1, it's not even important to go to refer to your table, as long as you found your neutral axis correctly, and we said our neutral axis was 87.86 millimeters. As long as this one is correct and that one is correct, for you to find the H1, you just have to subtract this from this. It will give you H1. Okay, I think next time we are going to this should be wise for you in advance to put here H, okay, so that you can say H1 and H2. So what I will do is it will just be wise in next time as you solve to put H at the end of your table, so that you don't really have to be solving yours. Once you find your neutral axis, you can solve these in advance. Okay, so I'm showing you that. Okay, so let me just duplicate all the figures here so that we see how best we can solve that. I think here we had the 680,000. Then the next one we had the 400,000. Then here we had 150,000. This is how our table looked like. So I have added another column for H because next time I don't want to start calculating H when I had the chance to do it on the table. Okay, so how do we calculate the H? I'll just subtract Y, this one minus that one. Okay, so it's going to give me 175 minus 87.86. Okay, what should it give me? Punch that into your calculator. That should give me 82.14 millimeters. Please remember the units are millimeters. Okay, for the second one, I'll again do 100 minus that one. That should give me 12.14. So this should give me 12.14. So I'm going to do 100 minus 87.86. Now remember, these are absolute figures. This is not a displacement, it's distance. So it's always going to be positive. The next one is 25 minus that, or this one, because sometimes it might confuse you. Say, no, this looks smaller than the number is negative. Remember, I've said these figures are simply absolute. Okay, so when we subtract 87.86 minus 25, that should give us in the calculator 62.86. So this is how you find the H1, H2, H3. You can do that right from the table, so that when you come to this, you don't begin to calculate, you just pick your figures. We already have our area, see? We already have our H1 there. So area H1, area H1, area H1, area H2, area H3. So that's how you should work out smartly. Okay, so just allow me, I should copy these figures right there for easy solving. So H1 is 82.14, H2 is 12.14, H3 is 62.86. Now you need to copy these figures correct and punch your calculator correctly, because you don't want to make a mistake. Once you make a mistake, everything below is going to be wrong. Okay, so let's deal with one, since we have H1 and D. So this is going to give you B1, remember now, it's 100 times that one, it's 40 to the power 3. See, it's this way, which is B, then D. Okay, over 12 times area 1, it's from the table, we have 4,000 multiplied by H1, it's here, 82.14 squared. So punch this into the calculator. Let's see what you are going to get. Okay, so from my calculator, it's giving me 251.73 millimeter to the power 4. Okay, so that is the number that at least you should get if you are close to that. Then we go for H2, which we are going to say B2D2 to the power 3 over 12 plus, this should be plus, guys, not multiplication, plus A2 H2 squared. Okay, we already have these numbers. So B2, again, remember, this is 2, so this is 40 by 100. That should give you 40 by 100. So 40 by 100 to the power 3, okay, over 12 plus area, you get it from the table, it's 4,000. I would like to put these in the bracket so that it doesn't confuse people. Plus area 4,000, you know, that multiplied by H2 is 12.14 squared. Now, if you do your math correct, the number in the calculator should give you 39 22851.73. Okay, let's see what it should give us. Now, what I want you to do is to work out I3. Do the same, what I've done here to be B3, D3, 3 over 12 plus A3. Do the same. I want you, let me hear you in the comment section, or whoever has gotten it correct. The answer should give you 24,958,277.6 millimeter to the power 4. That's what it should give you. So you see, we have worked out I1, we have worked out I2, you have also worked out I3, which should give you that. Right, so that is our moment of inertia 1, moment of inertia 2, moment of inertia 3 for the respective. Now we need to find the total. So for you to find the total, you just have to sum this one and that one and that one. So the total moment of inertia, let me use black for differentiating purposes. The total is equal to I1 plus I2 plus I3. That's what we have. So when you sum this one and that one, just put them in your calculator. It should give you the total moment of inertia to be 56,402,381.06 millimeter to the power 4. So that's how you find that. This is for question 2, remember. Then question 3, they asked us to find the maximum bending stress. Number 3, they asked us to find the bending stress. So remember, our principal equation was M over I is equal to stress over neutral axis is equal to E over radius of curvature. This is the question that we started with, and we said that it's one of the most important equations under this topic. Now, see, they have given us what they are asking us to find, of course, is this one, bending stress. They have given us the bending moment to be 4 kilonewton meter, right? This one, we have already found it, it's there. This one, we already found it, it was 87.86 millimeters. You see it? So we just work around this one to find that one. Okay. Now, something that is very important that you have to notice is these units are in millimeters, and this one is also in millimeters, but this one is in meters. So it is very easy for you to convert this one to millimeters than converting this one to meters. Okay, so we have got 4 kilonewton meter, which we have to convert it to. We have to convert to millimeters. So to convert to millimeters, we just multiply by 1,000. That should be very easy. Okay, so now let's convert that into the it should give you 4,000 kilo Newton millimeters. That's how you do that one. Okay, so that's what it should do. It should be, but if you want, you can convert this one to meters by multiplying by 10 to the power negative 12. I choose to go the easiest way. It's not worth it to live a difficult life. Life is short. Okay, so let's solve. Let's solve now. That's the only thing that we need. Okay, let's solve. How do we solve this? Just make that the subject of the formula by multiplying that. So that should give you stress I is equal to my divided by I divided by I. So maximum bending stress is equal to M multiplied by that over I. So this should give you bending moment. It's 4,000. Now remember there is a kilo. A kilo is 1,000 also. Wow, the space has become small. Let me just write it here so that everybody can properly see it. Okay, we don't have to rush. So my M, remember we said it's stress is equal to my over I. Okay. So bending moment is 4,000. There's a kilo Newton millimeter. But remember that kilo is 1,000. So at this point we need to convert it. So it will be times 10 to the power 3, which is 1,000. So it will be Newton meter over I is there, 56,402,381.06 multiplied by, this is to the power 4, multiplied by I, it's 87.86 millimeter. So you see, this is millimeters, sorry, that should be millimeter. So this one and this one and that one, they are going to cancel and they'll leave 2, because this will be 2 times 10 to the power, squared, so it will cancel by 2 here. Now, the other easiest way, if you don't really want to write bigger numbers, is, you see, there are 6 zeros here, so you can remove 1, 2, 3, 4, 5, 6, and that is mega, so it will be 4 mega Newton millimeter. You get a point. Even here, you can move from here 1, 2, 3, 4, 5, 6. It will be 56.4 mega millimeter to the power 4. Therefore, mega and mega will cancel, so the numbers are going to be reduced, but the answer will come out the same. So once you punch this into a calculator, it should give you 6.23 Newton millimeter squared. Okay. That's the final answer. That is the bending stress that we have. So this is how you solve these questions. They are very simple. All you need to do is practice, and you really need to get hold of your calculator, because most of the mistakes do not happen in computing these numbers, but they happen by misusing the calculator. So remember, the most critical point is number 1, finding the y as you move from here to the middle, from here to there, and from here to there. You need to know that. Number 2 is finding h. Now, I've told you that h, use the table, extend, put another column, then use that column to find your h. Then everything should be easy. See you in the next lecture.